In algebra topics, the distributive property usually looks like this. We use the number on the outside of the parentheses to multiply each term on the inside of the parentheses. So, 2 times 3x is 6x, 2 times 4 is 8, and our final answer is written as 6x plus 8. However, let's flash back to elementary school before we go too far. If I were to ask you to multiply 4 times 13 in your head, could you do it? Pause the video and give it a shot. That's pretty tough, right? Here's the answer to check your math. 4 times 13 equals 52. But did you know there's a method that can make this easier? Instead of working with 13, a tough number, we could instead split it into two easier numbers to work with, 10 and 3. 4 times 10 is 40, and 4 times 3 is 12. If you add 40 and 12 together, you get 52. This method we just used is the distributive property, and it could be written like this. Let's see a visual showing why this works. 4 times 13 can be drawn as 4 rows of 13 squares, and that's 52 total squares. If I split these 52 squares into 4 rows of 10 and 4 rows of 3, do any of the squares disappear? Nope. Still the same amount of squares. Even though we split the number to make it easier for ourselves, nothing about the final answer is changed. Let's use the same visual approach to relook at the algebra example we saw earlier. 2 times 3x plus 4 can be drawn as 2 rows of 3x's and a 4. If I split the 3x's in each row away from the 4's, the blocks don't disappear. We're just multiplying them separately before putting them back together. Let's close this video with a few more algebra examples, including common things to watch out for. Here are 3 distributive property problems. In the first example, it's common to forget the minus symbol acting as a negative sign. 2 times 5x is 10x, and 2 times negative 3 is negative 6. And our final answer is 10x minus 6. However, it's common for people to accidentally write 10x plus 6. The second example does not appear to have a number in front of the parentheses, and it only has a negative symbol. In cases like this, the negative symbol actually represents the number negative 1. Therefore, we distribute negative 1 to get negative 1 times 4x, which is negative 4x, and negative 1 times negative 1, which is positive 1. And the final answer is negative 4x plus 1. Finally, the third example has a similar situation. What do we do with the plain x that doesn't have a number attached to it? This again is a situation where the number 1 can be used. So, negative 3 times x means negative 3 times 1x, which is negative 3x. Negative 3 times 7 is negative 21. And the final answer is negative 3x minus 21.